I do. I very much enjoy teaching this class. Thank you for being here. And you're like, yeah, like I had a choice. I know. Some of you, if you had a choice, you'd be like, I would never take another math class again, or at least not geometry. But I hope that even if you don't necessarily enjoy the material, that you do enjoy the class. Because sometimes that happens. All right. Enough of that mushy stuff. So today we're going to be looking at conditional statements. Okay? You are very used to conditional statements. You hear them all the time. Okay? The bully. If you look at me like that again, I'm going to punch you in the face. That's a conditional statement. Your parents. If you clean your room, you can go out with your friends on Saturday. Right? Your teachers. If you fail this test, you're likely to be failing the class. Those are all conditional statements. They all have an if in them. Okay? Now, most of the time, the conditional statements that you hear are one thing happens and then a different thing happens as a result. Okay? They're usually time-bound. The conditional statements that we use in geometry mostly are not time-bound. They're more of the variety, if it fulfills these conditions by its very existence, then this is also true. I'll give you an example. If two angles are vertical angles, then what do we know about them? They're congruent. If they fulfill the condition of being vertical angles, then they are congruent angles. Right? If they fulfill this first condition, then we know that the second thing is also true. Okay? So, a conditional statement, by definition, is any sentence that can be written in the form, if P, then Q. You're like, what the heck are P and Q? P and Q are just stand for some phrase, right? It's just a lot easier to write that than write if some phrase, then some other phrase. So, if P, then Q. If you're writing this in symbols, I don't remember if this is in the notes anywhere, but sometimes you'll see it written this, P, arrow, Q. Please write that into your notes. This means implies. P implies Q. Knowing P ensures that you know that Q is true also. All right, so the phrase after the word if is called the hypothesis. Now, this is not quite the same as hypothesis in science. What is hypothesis in science? Yeah, it's an educated guess. The hypothesis here is the conditions that must be fulfilled. If these conditions are fulfilled, then we have the part after the then, which is called the conclusion. So the hypothesis are the conditions that need to be fulfilled. The conclusion is, well, what do we know about it after these conditions have been filled? Okay? So we're going to do a little bit of this. We'll do one that is time-bound just to show you how it works. But we'll, like I said, mainly stay away from things that are time-bound because it gets confusing. So identify the hypothesis and the conclusion in each conditional statement. Notice this one is already in if-then form. If today is Thanksgiving, then today is Thursday. By the way, is that a true sentence?
Yes.
Yes. And someone will occasionally go, but today's not Thanksgiving. I didn't say it was Thanksgiving. I said, if today is Thanksgiving, then today is Thursday.
Tomorrow.
Pardon?
What about tomorrow?
What about tomorrow? I said, if today is Thanksgiving. Is today Thanksgiving right now?
No, what if I
No. Answer my question, not anything else. then that's it. Okay? So, the hypothesis here is the part after the if. It does not include the word if, ever. The hypothesis, today is Thanksgiving. Likewise, the conclusion does not contain the word then. What do we also know? We know that today is Thursday. If we were to switch the hypothesis and the conclusion, and we're going to do that on some sentence in a little while, is this a true statement? If today is Thursday, then today is Thanksgiving. No. How can I prove that that's false? I need a counterexample. Well, today is a perfect counterexample, isn't it? It's Thursday, but it isn't Thanksgiving yet. Okay? Sometimes they're not written in that order, right? And sometimes you'll hear conditional statements. Okay? If you'll hear things where the if is the second part. An angle is obtuse if its measure is 130. So the hypothesis here and notice we'll do a little bit of English in this. What part of speech is that? Yoinks. Nobody knows that? Come on, I know that you do. Put your English hat on for a second. It's not a noun. It's not a verb. Wow. Seriously, I'm going to send a strongly worded email to the English department. It is a possessive pronoun. You've heard of those, right? You know what a pronoun is? It's a noun that's lost its amateur status? No? Okay, so someone got the joke at least. Okay. A pronoun is a word that stands in the place of a noun. What's the noun that it's is talking about? The angle. So we'll replace that with the actual noun. An angle's measure is 130 degrees. The conclusion is the angle is obtuse. So when you're writing the hypothesis and the conclusion, you don't want to have any pronouns in there. You'd like to replace it with the noun that it stands for. All right. Oh, here's the part with the arrow. I couldn't remember if that was in the notes or not. I need to start reading my notes every morning before I teach the lesson. Honestly, most of the time. So symbolically, if P then Q is written P arrow Q, which is read P implies Q. As I pointed out a minute ago, sometimes this is a temporal meaning that once P happens, then Q will also happen. As I said also, more often in geometry, we mean that if something belongs to the set of things called P, or it fulfills the qualities of that, then it also belongs to the set of things called Q. So you guys have seen Venn diagrams before, yes? Yes. Where do you learn about Venn diagrams? I have zero idea. Pardon? What did you use them for?
English, sometimes. Yeah, English, science, maths, most of
Okay. So, yeah, they're used in lots of different fields. So,
anything where you have to compare and contrast.
okay, I can see how you might do that. So here, dog implies mammal. So as an if-then sentence, this would be if it is a dog, then it is a mammal. If it belongs to the group of things that are dogs, then it belongs to the group of things that are mammals. Okay, this is how you would draw the Venn diagram for that. All right, let's move on. Page 2. So here, we want to write a conditional statement for each of these. By the way, it's not at all important that you know the terms in order to do this. Okay? How many of you know what a succulent is? Yeah, not very many. Okay? A cactus is a type of succulent. Okay? It's something that retains water in the plant itself. But that's not important. You don't need to know that in order to write this as a conditional statement, because they're talking about everything that belongs to this group has this further quality. So since it is plural here, I'll use if they instead of it. If they are succulents, then they are leafless. It's also not important that you know whether this is true or not. Okay? Especially if you don't know what a succulent is, well, then you might not know if they're leafless or not. Okay? So for this one, again, it's plural, so I'll say if they instead of if that, it. If they are what? Robins, then they are birds. Okay, conditional statements have a truth value of either true or false. They are always either true statements or they are false statements. Here's something that trips students up. They are false only when a true hypothesis has a false conclusion. Okay, and I find that this is difficult for a lot of students and it bugs them. I'm going to give you what I think is the best example of this that I can think of. I've been using this for years. It helps most students. Let's say that I make the statement, if I win the lottery, I will give each of you $1,000. Okay? What is the only way you can know that I'm a liar? Oh, what? No. What if I didn't win the lottery? Do I have to give you $1,000 then?
No.
No.
Oh, if you win the lottery.
And
don't give us $1,000.
So a true hypothesis, but a false conclusion. Okay? So if I make that statement, the only way that it's false, I have to win the lottery, I have to fulfill the hypothesis, but then I have to back out on my deal to give you each $1,000. By the way, this is never going to happen because mathematicians know the odds. They don't play the lottery. It's a sucker game. It's designed to separate you. I'm in the middle of a sentence at the moment. It's designed to separate you from your money. When it first came out in Texas, they started the lottery, and people were like standing in line to get lottery tickets. I'm like, you're standing in line to pay taxes. Okay, we used to say it was a tax on, well, it's not very nice, but we'd said it was a tax on stupid people. Yes?
But then there are also about the decision to use lottery as a way to gain money.
There have been some that have done it successfully. There are many more who've done it unsuccessfully. So, yeah, it's a sucker bet.
Sometimes mathematicians prove that by putting enough amount where the money averages out, they need more money.
Yeah, in the end, if you play it long enough, you will lose money. And if you just play it once, you're almost guaranteed to lose money. Anyway, so here, let's determine the truth value of each of these sentences. Remember, if it's false, we just need one counterexample. One case where the hypothesis is fulfilled, but the conclusion is not. So, if this month is September, then next month is October. True or false? That's true. No, do not. Nobody thinks you're clever when you do that. Please stop. Okay? Nope, stop. I don't want to hear it. Do you understand? All right, next. If two angles are acute, then they are congruent. Is that true? That's false. We need a counterexample for that. So, 1 and 2?
1 degree and 2 degrees.
Okay, so one angle has measure 1 degree, and the second that's really messy, has measure 2 degrees. When you're giving a counterexample, you need to give a specific case, not some, well, it could be, blah, blah, blah. No, give a specific case. Okay? Don't say something like, I have sometimes students who go, well, they don't have to be congruent. Prove it to me. Okay? Here's one of my favorite examples. If 9 is divisible by 2, then pigs can fly. True or false?
Well, divide evenly?
Yeah, when you say something's divisible, that means evenly divisible. This is a true sentence. Why? Because you can't find a counterexample. 9 is not divisible by 2. So I can never fulfill the hypothesis. So this is, I mean, you can make all kinds of ridiculous statements that are true statements, but aren't particularly helpful. Okay? This is the case of, I'm not going to win the lottery because I don't ever play it. So I can never be lying to you if I say, if I win the lottery, I'll give each of you $1,000. Since I never play the lottery, that first thing's never going to happen, so you can never prove me a liar. Okay? This one bugs students. They don't like it. They don't like that a false conclusion leads you to a true sentence. A false hypothesis. All right. Let's move on to some related statements. So the negation of a statement either adds or takes away the word not. So the statement, I am tired. The negation is, I am not tired. It's not, I am energetic. It's not, I'm feeling great. It's not anything else. It has to be the exact opposite. If the statement is you are not slow, the negation is you are slow. Okay? It's always add a not or take a not away. All right, page 3. So some related conditional statements. The converse of a conditional statement switches the hypothesis and the conclusion. Now remember, the if and the then stay put. So you're just switching the hypothesis and the conclusion. The inverse of a conditional statement negates the hypothesis and the conclusion, and then the contrapositive of a conditional statement both negates and switches the hypothesis and the conclusion. So frankly, what I tell students to remember, they're like, I can't remember which one the contrapositive is. I'm like, it's the longest word. It does the most stuff. I think that's a fair way to remember it. So let's use the conditional statement. If an animal is a cat, then it has 4 paws, to write the converse, the inverse, and the contrapositive. Find the truth value for each and for the original. So, the converse. We want to switch the hypothesis with the conclusion. So, notice it has an it here. That pronoun stands for an animal. So typically we'll replace that with an animal. So if an animal has 4 paws, then it is a cat. By the way, is that true or false? That's false. What would be a counterexample for that? A dog, a wolf, horses don't have paws. Rabbits do, though. Okay? All right, inverse. We always go back to the original. Now we're going to negate both parts. So if an animal is not a cat, then it doesn't have 4 paws. If an animal is not a cat, then it doesn't have 4 paws. Is that true or false? False. For exactly the same reasons as this one, right? Right? If we pick a dog, it's not a cat, but it does have 4 paws. And then the contrapositive, we want to do both. So we want to switch the hypothesis and the conclusion and negate both of them. If an animal does not have 4 paws, then it is not a cat. I will say occasionally students on this are like, oh, I knew a cat that had 3 legs, so it only had 3 paws. We're talking in somewhat generalities here. Okay, we're not going to get silly about it. Is this true or false?
True.
It's true. If it doesn't have 4 paws, well, that's something that is part of what a cat is. What about the original? If an animal is a cat, then it has 4 paws. That's also true. It turns out that the truth value for the original and the contrapositive are always the same. The contrapositive and the original always have the same truth value. The converse and the inverse also always have the same truth value. Now, is it possible for them all to be true? Yes. Oh, I see the wheels turning there. Well, how about if I say this? If it is a square, then it's a quadrilateral with 4 right angles. The converse of that, that's a true statement, right? The converse of that would be, if it is a quadrilateral with 4 right angles, then it's a square. Oh, that's not necessarily true, is it? Because not all the sides are congruent. So that's a case where the converse doesn't have the same truth value as the original. How can I change that? Well, do the whole definition of square. If it is a square, then it's a quadrilateral with 4 right angles and 4 congruent sides. Now if I switch it and do the converse, if it is a quadrilateral with 4 right angles and 4 congruent sides, then it's a square. That's true. So typically things that they're all true is because the hypothesis and the conclusion are really the same. They may be different words, but they're really talking about something that is exactly the same. That make sense?
Yes.
All right. So we call those sentences that have the same truth value logically equivalent. In other words, you can replace one sentence with the other one, and from a logic standpoint, from a truth standpoint, it means the same thing. So, as we said a moment ago, a statement and its contrapositive are logically equivalent. And the inverse and the converse of a statement are logically equivalent. If you really want to bake your brain for just a second, think about this. The contrapositive of the inverse is the converse. If you take the converse of a sentence and then do the contrapositive of it, you've got the inverse. Okay? Any questions about any of this? Yes, sir.
Would you consider the original as positive and the inverse and converse as negatives? In a normal statement that does not use it as
Well, I don't know what you mean by negatives, because they can all be positive. They can all be true, or they can all be false. Okay? All right. Your assignment is in the book.